Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 10, 2025, just 2 days ago. This paper shows how a new technique can nearly triple the accuracy of a Llama 3 model on a challenging math reasoning benchmark. The paper is titled, Skip a Layer or Loop It. Test Time Depth Adaptation of Pre-trained LLMs, and it really challenges the idea that an LLM needs a fixed structure for every single problem. The core concept is that you can dynamically skip or repeat layers to build a custom, better model for each input. So how does this actually work? Well, this first diagram gives us a great visual. It shows their method, which they call chain of layers, or CoLa, creating a custom path for each input. As you can see, it can skip layers, like jumping from the input straight to layer 2, which is great for simpler problems. But it can also create a recurrent loop, reusing a block of layers for more iterative refinement on harder problems. This whole process is guided by a smart search algorithm called Monte Carlo Tree Search. Building on that idea of adaptive depth, this next chart really shows us what's happening under the hood. It compares the number of layers the model chooses to use against its original fixed depth, which is that dotted line near the top. The solid bars are the total layers used, while the hatched bars show the number of unique layers. What's fascinating is that even when the model corrects an error, going from a wrong to a correct answer, it often uses fewer layers than the original. This suggests the fixed model wasn't underthinking, but was actually overthinking and getting confused. So, these next charts break down exactly what happens to the model's answers. The bars show the proportion of 4 different outcomes. The most important one is the green section. That's where the original model was wrong, but this adaptive method fixed the mistake. You can see across all the models, especially on the harder Dart math problems, there's a huge green chunk. This means the chain of layers method is successfully correcting a lot of errors. It really reinforces that idea that the fixed model was getting stuck, and a more flexible path was the key to finding the right answer. Okay, so these next charts give us a much clearer picture of which specific layers are being adapted. On the left, we have the skip rate, and on the right, the repeat rate, shown for both the Llama 3B and 8B models. What's really interesting is the clear pattern in the skip rate. The model almost never skips the first few layers, but it frequently drops the middle ones. This really visualizes that overthinking idea we talked about. The adaptive method is actively trimming unnecessary computation. The repeat charts on the right show that various layers get looped, adding deeper iterative thinking when needed. So putting all these pieces together, it's clear that a one-size-fits-all model depth is a major limitation. This chain of layers approach shows that by treating layers as modular blocks, models can dynamically adapt their own structure. They can use shallower paths for simple problems and create deeper recurrent paths, which is like a loop for more iterative thinking on complex ones. Crucially, this often fixes errors by skipping unnecessary middle layers, suggesting the original models were simply overthinking. It's a fascinating approach. That's all for this week. Thanks for tuning in.